How's it going, everyone? Welcome. Julian Gonzalez here, and now finally we have some audio. In the last video, we have some technical issues that now are solved. So, here, yes, as you can see in the background, well, this is early in the morning. I don't have lights right now. I need to hire a handyman to actually put that. So, today, let's go into look at the chapter 3, dig into the root of a JavaScript as a way to now finally understand is this low level features that virtually affect every line of code that we write, and also to understand is the feel of JavaScript and the apps and its flow, right? Now, in that, because this chapter mention is chapter 1 and chapter 2, I'm not gonna mention any one of them. But I do is to make a quick recap of this chapter 3 when this particularly low level features, according to Kyle Simpson, are the iteration, the way of now JavaScript implement this standard way of consuming data from a data source as one chunk of data at a time, in because we have this particular pattern, which is something that is not new. It's part of the design pattern that implements a data structure that points or that have a reference to the underlying data source, right? And expose is a method called next. Now, when we call that, it gives you now a value that contains the value and the a boolean uh, done, which is, hey, is this the end of these collections? All right, and because this pattern, what allow is to consume these chunks of data each one of a time, and I do find that very interesting because uh, something that something that we do, or something that I do as a JavaScript programmer a lot of the times, is that we write or I write programs to manage data and process that. But usually is that to consume data and then to process that data so we can make some decisions on that data. Now, because the algorithm that you write or the patterns that you develop to do so is going to impact how maintainable your solution will be. And this is not only true for right now, this particularly, how do you call it? This particularly code or this particularly series of steps for consuming data, but also is for others as well. But most of the time, the program what it does is that is consume data and process that so we can make decisions on that. And I say we because usually you work in a team. Now, having said that, it's now for us to understand the way of how now we can consume these kind of data structures, uh, or in other words, how we can is consuming is iterators, okay, in EXX. So we have now two ways to do that. We have is the spread operator. We also have is the for operator, and for off loop operator. And the spread operator actually it follow a very well defined algorithm that say, hey, whatever you have here, okay, um, and whatever by I mean is whatever expression, and these expressions, we can take a look at the script if you like to. Let's why not? Okay, which is that is part of an expression, a spread operator. I will say that is some sort of iteration, I will say. Statement and declarations, semantics, variable expression, iteration statements, do while for continue, or it can be described in statement semantics. Might be here. No, expressions. I mean, it is at the end of the day, it's an expression. Primary expressions, binder identifiers. Let me see if I can find it, because if it's not, I'm gonna give me a couple seconds more. Bitwise additive multiplication exponential operators. Okay, in any case, spread operator, spread element. They are in array initializers. Okay, that's interesting. Primary, exact. I was quite close. Exactly, it is an expression, all right? But they mentioned that as an array initializer. Okay, okay. An array literal is an expression describing the initialization of an array using a list of 0 or more expressions of each which represents an array enclosing in square brackets. The elements needs not to be literal. They are evaluated each time the array is initialized. The array initializer is evaluated. Okay. Elision or the spread operator. It's interesting. So here is the way how you can now is consume this kind of operators, right? So what it's gonna do is that the spread operator, like this, it's a hey, this is an assignment, and this assignment can be is a conditional assignment, and this condition can be is a short-circuiting assignment, or it can exactly a short-circuiting assignment, all right, or a ternary operator. So this short-circuiting assignment, which is the and or the or even nullish collision, all right, where their behaviors here. So you can think like the and like a gate, that if you pass now a falsy value here on the left side, it will return you that falsy value. But if the value is true, it's gonna return you is the value on the right. The or behave now in terms of, hey, if you pass me now a boolean, if you pass me now a true value, I'm gonna return you that. But if it's not, let me now check at the next one if that is true and give it to you back. So this is quite interesting, because most of the time we think that the evaluation of these expressions result is in a in a in an evaluation of a boolean value, right? That is going to return true or false, and it turns out that it what happened is a coercion of those values. It's going to coerce this value into a boolean, whether it's in the and or the or, and it's gonna do that. Whereas now the coalition is say, hey, if this value is undefined or null, so let me now return you is the values on the right. So this is the short-circuiting expressions, right? And also we have is the conditional expression, or with question mark, the ternary operator. This is like essentially is an if-else statement, but as an expression. Okay, so we have this conditional expression. We also have now the yield expressions, which is using is the generators as well. All right, yield like that. The syntactic context immediately following yield requires the user require use of the input element, regular expression, or template tail lexical go. Yield expression cannot be used within the formal parameters of a generator because any expressions that are part of a formal parameter are evaluated before the resulting generator in its resumable state. An abstract operation related to generators are defined here. So in other words, you can put this into a parameter, so on and so forth. Now, so this is yield, all right. Let me see if they mention how yield is evaluated here quickly. Evaluate generator body, instantiate generator function objects, and evaluation. Oh, there you got it. It returned the yield of undefined. Okay, and yield is an abstract operation that takes argument as a value, an ECMAScript language value, and returning either normal containing an ECMAScript language value or an abrupt completion. It performed the following step when called: let the generator kind get generator kind. Okay. If generator kind is async, return async generator yield. Otherwise, return the generator yield. Create iterator result object with the value of false. So this generator yield, which is another abstract operation here, as we go into the generator abstract operation. Anytime we look at the abstract operations, we mention is this algorithms that happen without our consent as JavaScript developers to do stuff that are relevant for the JavaScript engine. So, for example, coercion or equality, right? So yield is this, okay? If the generator kind is not async, return the generator yield. Again, another iterator abstract operation that takes an argument iterator result, an object that conforms to the iterator result interface, and returns either normal completion containing an ECMAScript language value or an abrupt completion. It performed the following step when called: let get context be the running execution context. So in other words, it creates now a new running execution context. And this running execution context here is now this you can think of this like an object that you can have access to at runtime, okay? And it's made of the lexical environment that is used to resolve identified reference made by code within the execution context, the variable environment, which hold binds created by variable statement, and the private environments. But usually is that. And you also have another component, additional state component for generator execution context, which is the generator. The generator that this execution context is evaluating. So again, this execution context, right? They are devices. You can think of it like an objects that is used to keep track of the code at runtime. So at any point in time, there are at most one execution context per agent, and the agents, you can think that this is like some sort of thread, all right, that is actually executing the code, which is an agent here is this unit of execution in JavaScript. And the unit of execution is what is the minimal stuff that JavaScript requires in order to process, in order to execute that particular code. And here we have is things like, well, it needs the execution context that have is the lexical environments, and also contain is the uh, code that is going to be evaluated at runtime. It also have a call stack, okay, where the call stack is used to track the execution context, and the execution context is used to track the runtime evaluation of the code. This is interesting because we tend to think that the thread of execution as a way to have an understanding of what's going on, but each one of these contexts are very well explicit and defined. So the execution context is used to keep track is the it is used to keep track it is it is used to track the runtime evaluation of the code, okay, whereas the running execution context, it is used to keep track of those execution contexts, or the call stack, it is used to keep track of those execution contexts. And a running execution context, okay, where at any point there is at most one execution per agent, and that is actually executing the code. So in this agent actually is made of the execution context, which is a device that is used to keep track that is used to track the code at the runtime. All right. We also have is the call stack, which is used to keep track of this execution context. All right. And also we have is a running execution context. So the running execution context, which is used by the agent, okay, and the agent is made of this component. The agent is made of the device that is used to keep track of the code at runtime. The the device that is used to keep track the code at runtime. The device that is used to keep track is the execution context. All right. An agent record that contains several of these values, internal values that is used, and an execution thread. Here is the execution thread. Mm-hmm. An agent execution thread execute algorithm step on the agent's execution context, independently of other agents, except that an execution thread may be used as an execution thread by multiple agents, providing none of the agents sharing the thread have an agent record whose chem-block field is true. Some browsers share a single execution thread across multiple unrelated tabs of a browser window. For example, while an agent executing thread is executing algorithm step, while the executing thread is executing algorithm steps, the agent is the surrounding agent for those steps. This step uses the surrounding agent to access the specification level execution object held within the agent. Okay, the specification level execution object held within the agent, the running execution context, the execution context stack, and the agent record. But this running execution context is is that the specific device that is used to track the runtime evaluation of the code. One of them is to keep track of the runtime evaluation of the code, and the other is to execute the algorithm steps. So this runtime evaluation of the code, okay, one of them is for executing is the runtime evaluation of the code. So it's like evaluating all of its expressions at runtime. And the other is evaluating is the algorithm step. So again, the idea is starting to slowly clarify here, but it turns out that we have is now the execution context, which is a device we use to keep track the runtime of the code. All right. The other is the execution. This is the execution context. The execution. The threat, the agent, which is made of a set of execution context or a set of this device that is used to keep track the evaluation of the code at runtime, the execution context stack that is made of all of these execution contexts, okay, and the running execution context. All reference to the running execution context in these specifications denote the running execution context of the surrounding agents. The execution context stack is used to keep track execution context. Exactly. In other words, it's used to keep track is that the run is used to keep track the runtime evaluation of the code. And the runtime evaluation of the code can be is code evaluation. Okay, it can be a function, it can be the realm record for which associated code access ECMAScript resource, and it can be a model or a script. If there is no original script or model in the case of the original execution context. So this execution context is just a way to evaluate the evaluation of code at runtime. So this device that allows to keep track is the evaluation of the code at runtime, okay, is not the same as the executing thread, because the executing thread is the execution is executing the algorithm step. So while an agent executing thread is an executing algorithmic step, okay, this is going to evaluate this line after the another. The agent is the surrounding agent for those steps, and the step is used for that. So it's starting to make a lot of sense with the execution context, because execution context is not the algorithm, it's just device that is used to keep track of the code evaluation. And this code evaluation, or exactly the evaluation of this code, and this code can be code evaluation state. Any state needs to perform, suspend, resume evaluation of the code associated with this execution context. It can be a function. If this execution context is evaluating the code of a function object, then the value of this component is that function object. If the context is evaluating the code of script or model, the value is null. You have also the realm, right? And before it is evaluated, all ECMAScript code must be associated within a realm. Conceptually, a realm consists a set of intrinsic objects. It's interesting. So now starting to make a lot of sense. So thing is starting to make a lot of sense here. So a realm consists of a set of intrinsic objects. An ECMAScript global environment and all the ECMAScript code. Okay, so they have now intrinsic objects. An ECMAScript global environment, all the ECMAScript code that is loaded within the scope of the global environment, and other associated state and resource. So now realms are a set of intrinsic objects. Are a set of intrinsic objects. And these intrinsic objects, okay, an ECMAScript global environment, okay, an ECMAScript global environment, and all the ECMAScript code that is loaded within the scope of the global environment and other associated state and resource. A realm is represented in this specification as the realm record, with the fields specified in the table 22. So this is the intrinsic object that it has. Agent signifier, the agent that owns its realm. Intrinsic, a record whose field names are intrinsic key and whose values are objects. Okay. Global object, an object, the global object for this realm, the global environment record, the global environment for this realm, the template map, a list of records with field sites, a template literal, personal, and an array. An array template records are canonized separately for each realm, using it as realm record template. Each size values versus node, there is a template literal, the associated array value, it is corresponding template object that is passed to tag functions. Once parse node becomes unreachable, the corresponding array is also unreachable, and it will be unobservable if an implementation removes the pair from the template map. Loaded models, a list of loaded model request records using the import. A map from the specified string imported by this realm to resolve models records. The list does not contain two different records. R1 and R2 such that model request R1 and R2 is true. As mentioned in host load imported model, loaded model in realm record is only used when running an import expression in a context where there is no active script or model. Host defined. Anything default value is undefined. And they also have is the host defined. Anything. A default value is undefined. Field reserved for use by a host. Whoever is going to execute the code. That needs to associate additional information with a realm. And a host is an external source that further defines facilities listed in Annex D, but does not further define other implementations defined or implementation approximation facility. In informal use, a host refers to a set of all implementations such as the set of all web browsers that interface with this specification. Exactly. So the host is somewhat like the platform that this code is can be executed, and usually is the browser, known as the host. In other words, facilities that are host defined are often further defined in external specification. A host hook is an abstract operation that is defined in whole or in part by an external source, and all hooks must be listed in Annex D. So Annex D here is describing is the host layering point. Okay, host hook, callback job, enqueue finalizer, enqueue generic job, promise, time up. So the hosts are going to provide this. which is the host and queue genetic job, host and queue promise job, host and queue timeout job, finalize import meta, get import meta, has source, load important model, get source, make job call, host promise rejection tracker, host resize array buffer, host define field, and host define objects like the global object. Mm-hmm. The global object, global this, infinity, nan, and undefined. Mm-hmm. So slowly but progressively, things started to make a little bit of sense here. Running job, preparation step before a cleanup step after invoking a job after closure. But again, it all starts because this can be quite long, you know. Uh, this is informative, exactly informative. Mm-hmm. Mm-hmm. Okay. So as we saw so far here, uh, as a way to understand is what the geo is doing. All right. That that is creating is an execution context. Okay. Like this, let the running execution context and this running execution context, right? Um, yeah, the running execution context is made of the agent, okay? There is at most one execution context per agent that is actually executing the code. This is known as the agent execution code. So when you talk about the running execution context, the spec describes this as an agent. And an agent is this unit of execution that JavaScript use to process your code. So what are the minimal stuff that it needs to process your code? How do you measure that you're going to evaluate your code? Pretty much like a uh, time units or weight units, all right, that you know what is the measure that is being used for that, right? And the protocols, the series of steps to determine, for example, what is a second, what is a meter, and what is a wave. So okay, this go beyond, but I do think that's quite important to do. Another interesting unit is that how a information is weighed. How do you determine that? So, for example, how the second is determined exactly. How a second is determined. How the unit second is determined. How the unit meter is determined. Mm-hmm. Mm-hmm. The definition of a second and a meter are based fundamental in physical constant, making them incredibly precise. But again, here we are looking is at this particularly definitions based on the physics, the material world. Okay? The second is defined using the Celsius 133 atom. Holy fuck. Specifically, 1 second is the duration of exactly 9 million 100. No, god damn it, this is 9 trillions in English, or 9 billions in Spanish. So 9,192,631,77 period of the radiation corresponding to the transition between two specific energy levels of the cesium 133 atom in the ground state. And also I would like to, okay, how the unit second is determining, how the unit meter is determining, how the unit of execution in an OS is determined. So the second is defined using the atomic transition. Since 1967, 1 second is defined as exactly 9 trillion period of radiation. Okay. Holy shit. Period of radiation corresponding to the transition between two hyperfine level of the ground state of the cesium 133 atom. This definition is based on atomic clock, which measure the incredibly precise and consistent oscillations of cesium atoms when exposed to microwave radiation at a specific frequency. This atomic standard replaced early definitions based on Earth This atomic standard replaced early definition based on Earth rotation or orbital period, which were less precise and variable. But I do find that I knew that the way how this second is determined is, I think, is by the time of the light, by the time of the light, something like that. It is based on the Earth rotation. The meter is defined in terms of the speed of light. Since 1983, 1 meter is defined as the length of the path traveled by light in vacuum during a time interval. Okay, the meter is defined in terms of the speed of light, right? Since 1983, 1 meter is defined as the length of the path traveled by the light in vacuum during a time interval of 1 and, well, you get the idea, of a second. And the second is the period of that. Is a period of radiations between two hyperfine level of the ground state. Before this, the meter went through several definitions, originally based on physical prototype bar, then tied to wavelength of a specific light emissions. Unit of execution in an OS. The unit of execution in an operating system is typically the process or thread, and this is determined by the OS design and implementation rather than a physical standard. I do mention this because, as you can see, the word unit is something that we as a human define a mechanism to try to understand something. I will say that. So units are mechanism, all right, or algorithm, the series of steps to determine so units are mechanism or units to determine what is or to determine how to measure or to understand, most likely. So units are mechanisms or algorithms to determine what is something. Units are mechanisms or algorithms to determine what is something. Units are indeed mechanism or algorithm for measuring and standardization. They provide a systematic way to quantify or to compare and communicate about things. More specifically, units serve as a measuring mechanism or comparing algorithm or communication standards, right? Or abstractions tools. But the point of that I'm making here is that anytime that we understand, anytime that you look the concept of unit, is because it means to us a human, unit is a tool that we use to determine how we're going to communicate, how we're going to express that, how we're going to measure, how we're going to compare this. And when we compare, measure, and communicate, now it makes a lot of sense. For example, in the realm of seconds, time, or in the realm of the weight, um, uh, like kilograms, or in the way, or in meter, in distance, right? And there are people that right now actually are complaining about that the unfairness things about of all of this unit, all of these standards or mechanisms that the white folks have created in order to oppress the rest of us. You know, it's like, I mean, they might have a point that the white folks actually create this in order to understand and measure and have a control of the world. That's mainly what it is. All right. But I do not think that that was the intent initially. The intent was to describe it, to use that in order to understand that, and then it comes the action. But yeah. So in other words, anytime that you look is a unit, is expressing is a mechanism, a series of steps to understand that, right? So what are the series of steps to understand that and to compare and then to communicate to others, right? Mm. So in this case, this unit of execution, for example, in the OS, is something that is determined by the OS. It's something that is determined by a bunch of people that create that OS. This is one. And mm, mm, the unit here. Okay, okay. So we were talking about this since now the execution context is used to keep track is the unit, all right, or is used to keep track is the runtime evaluation of the code. All right. So this code that is going to be evaluated at runtime, I need to somehow have something to a device, right? So you can think of this like a stopwatcher, right? It's like when I do this, I have now a device that I can use to keep track of that. For example, in track and field, when people are running, it's like, hey, I want to know is how much time it's gonna take me here. But this is not going to determine is the time. It's gonna determine is uh, the place, the location in which you are running your code. So in other words, the execution context is the execution context is a device that is used to keep track. Um, okay, so the execution context is a device that is used to keep track the is a device to use. Sorry. So the execution context is a device used to track the running execution or the runtime evaluation of code. Okay. Uh, and this runtime evaluation of code, or this device uh, that is usually with an agent, and an agent is this entity that have is this set of execution context. All right, it has all the execution context stack to keep track of the execution context, which it keep track if the runtime evaluation of code. Mm-hmm, the runtime evaluation of code in this execution context. All right, uh, exactly. An execution context contains whatever implementation specification state is necessary to keep to track the execution progress or it is associated code. Each execution context has at least the state component listed in table 23. But again, this device that is used to keep track, that is used to track, this device that is used to track is the execution context. Okay. Yeah. So this device that is used to track the running, the runtime evaluation of code. So you're gonna evaluate this code at runtime. So I have a device to check that the evaluation of the runtime code that it can be is a function um, that is the component of this is a function, a rel, which is a set of intrinsic objects, and the code evaluation. Any state need to perform, suspend, or resume the evaluation of the code, and followed by the script or model. So again, so an agent is a set of this execution context, which this device to use is this device used to track the execution, the runtime evaluation of code in JavaScript. Okay, and that is made of the function to determine which execution context it is. It's a function, it's a type of model, and the code in itself. And the other is, okay, that's when we make a lot of the simplifications. And the other is that the agent that is made of a set of running execution context is made of the call stack, all right? A running execution context, right? In all the reference to running execution context in this specification, denote running execution context of the surrounding agents, as well as an agent record and an execution threads. So except for that. So when you started to read more about the spec, you started to get a notion of what the things is doing. So anytime that a function, anytime that an execution context is created, this device that used to track the runtime evaluation of the code that internally have its components like a function, the realm, which is an intrinsic object. Okay. The code evaluation state. Any state needed to perform, suspend, or resume evaluation of the code associated with this execution context. All right. And it also have now is the lexical environment. ECMAScript code execution context have the additional state component list. So not only it has is these intrinsic objects known as the realm, it also have a property called functions that determine if this execution context is evaluated the code of a function object. All right. If it's not, it might be of the script or model, or it can be now is from the code evaluation state. And also it has now a lexical environment that is used to resolve identified reference. which is all of these variables name that we put in here. Similar to the variable environment here, identify the environment record that holds binding created by various statements within this execution context, as well as the private environment. And also, if this execution context representing the evaluation of generator has additional state component, listen here. It also have a component that is a generator. And the generator that this execution context is evaluating. In most situations, only running execution context. The top of the execution stack is directly manipulated by algorithm within this specification. Hence, when the terms lexical environment and variable environment are used without qualifications, they are in reference of those components of the running execution context. And an execution context is purely a specification mechanism and not need corresponds to any particular artifact of the ECMAScript implementation. This is the conceptual idea of this. It is impossible for ECMAScript code to directly access or observe an execution context. But again, it doesn't mean that it doesn't exist. But this execution context that is used to track the running evaluation of code that is made of the that is used by the agent, which holds now is this execution context. It also calls that queue an agent record, particularly to the agent, all right, which is this unit of execution of JavaScript, as well as the executing thread, which is evaluating is the algorithm step by step. So this is comprised is the agent. And here in the execution context, this has several components. So it has now this intrinsic object known as the realm. It also have a function to indicate, a function component to indicate that is this execution environment, is this execution context is a function, all right? It has another property to say, hey, if this is a script or a model, and the co-evaluation. And it also have now a lexical scope here, a lexical environment, variable environment, private environment. And if this is a generator, it has another component called generator. So with that, holy moly, bro. So with that, it turns out that when you yield a value, it's gonna call now the generator yield, which is an abstract operation here that takes an argument iterator result, an object that can form the iterator result interface, which is this contract. Hey, do you implement is this iterator? Okay, and returns either a normal completion containing an ECMAScript values or an abrupt completion, and it performs the following step when called. Let gen context be the running execution context. Assert that context is the execution context of a generator, and the generator be the value of the generator component of gen context, and get generator kind is sync. Okay, get the generator kind is sync, and it says set generator state to suspend and yield. So this execution context here, all right, that is a generator, that is a specific type of execution context, okay? It has now an inner property called generator state that indicates that, hey, let me now set that to suspend yield. Remove the gen context from the execution stack and restore the execution context that is at the top of the execution context tab as the running execution context. So remove the gen context. Okay, so remove the gen context from the execution context stack and restore the execution context that is at the top of the execution context tag as the running execution context. In other words, it's like passing control to whoever called this generator. Let the caller context be the running execution context. Exactly. Let the caller context be the running execution context. Be the running execution context, and resume caller and resume call context passing normal completion iterator result. If get content is ever resumed again, right? If you for some reason you can have access to, or you call that generator again, let the resumption value be the complete record in which is resumed, and assert if control reach here, get the context, get gen context, which is gen context. Then gen context is the running execution context again, and then return resumption value. But this is a yield here. So for example, you say yield 5 unexpected number. But it's interesting. Again, remember, this is a friendly JavaScript environment. But a yield cannot be in exactly. Let the generator kind be generator kind. The abstract operation generator kind takes no arguments and return no generator async or async. It perform the following: let get be the running execution context. So in other words, you cannot have that. If gen does not have a generator component, return no generator. Let generator be the generator component of jet, and if generator component is thing, get generator kind. So in other words, you cannot have this. You must define this inside of a generator. For example, like this. And it's inside of this that you are going to, so while I is 0, so while I is less than 3, do is this. So yield is I as a value, right? And then return it, and then return I. So it's gonna call is this sequence, okay, where now this sequence is gonna be used. Oh, but it must be like this. This is how you can tell this execution context, hey, execution context, this is now, hey JavaScript, this is now a generator execution context. And what I want to do is to say, hey, I want to now call that generator. All right. First, assert that object has an generator property. Here you say, hey, it's a sequence. You can say sequence and remove this, right? You can actually have access to the sequence to see if this actually contains now the symbol dot iterator. It says that this is undefined. What about in the prototype? It contains that, so it exists, right? So it has now is under the prototype, okay? Not as an internal property, not as in its own property, but as a prototype, okay? And therefore, since this now is an iterator, let me now call that. Oh, did I break that? Oh shit, yeah, I break that. Oh, because I never. Yeah, of course it breaks. Of course it breaks. And it breaks fast, bro. And it breaks fast. So the browser here is actually quite smart to say that. You say, let me do this, E++, and then yield that. Now it will work as expected. Now if I do this, so here comes is this. Oh, I think it's because I cannot mutate that value, which is a primitive. You are damn right. You are damn right. Okay. So while E is less than 3, now do this. It's a sequence, and then on the sequence, all right, I want to call this, but I want to consume this iterator here as it is. Unexpected token is this. Well, let me put it this way. What about this? And there you got it, right? But it all is describing is that how can we now consume this an iterator, because here this is the way of how we can define, this is how we can tell JavaScript, hey, this execution context that you are going to create when you call this function, it is now a generator type, and a generator type is now is going to evaluate that. Okay, is going to evaluate that is interest in generator yield. So the generator yield is going to now run that. Is going to tell to that context to suspend, remove from the call stack, and if at some point is ever resumed again, let the resumption value be the complete record in which it is resumed. So you're going to now pass is the value again to that. If control reach here, then generator context is running execution again, and then you return the resumption value. But all of this, because I wanted to wrap this up here, all of this is just to describe now for sure what is doing behind the scenes when we are consuming iterators. Okay, when we're consuming iterator, and what is now an iterables, which is this data structure that implement that iterator protocol. And when it comes to look at the another aspect, which is a closure, which indeed is created is on the function's definition. The closure is created when the functions have access to outer function. The function is created at, so the functions enclosures is it is surrounding. So the closure, so closures. So closures. But closure enclosed, it is surrounded here. Okay, so closures. So when a function is defined, it is attached. It is enclosed in scope via closure, and this enclosing scope that when you have a reference inside of a function from the outer scope, it creates now is this reference. It holds this reference so that the function, the inner function, can have access to. So this is one of the powerful features in closures. So in other words, closure is when the functions have access and continue to access is a variable from the outer scope in the inner scope, even after that function is executed at a different scope. So in other words, scope here is this set of rules that define, or is the set of rules that determine how variables and its reference are resolved, okay? But this is one characteristic of the functions. And another one is uh, that we can have access to the execution context. And the execution context, all right, is this device that is used to track the running execution, the runtime evaluation of code that is made of several stuff. So one of them is the functions, and one of them is to determine if this is a function execution, or to determine if it's a script or a model or a generator. And it also have now is the realm, this intrinsic object that you can have access to. And in this case, we can have access to this intrinsic object is via the this keyword. And you can determine this value is at how you call your function, right? So whether it's you call your function like this, and then you have access to the this, okay? The values that is gonna be resolved is to say, hey, do I have access to this variable here, or to this identifier here? In my rel, in this intrinsic object, do I have them? Or even I have declared that in the lexical environment? If it's not, then it does not. Not only this, which effectively are creating is a closure, but also is that you can now pass is a value to this object, all right? So you can pass now an object that is gonna be accessed to the function here. Holy French toast. Via the call, the bind, and this. I do think that that'll be all for this video, and that was quite mind revealing here, because at the end of the day, when a function definition is created, for example in this case, all right, and then somehow I would like to know what is the this, if I do think that I have access to, sequence is not defined. Okay. This is okay. Holy moly. So this is so this allow you to have access to this intrinsic object, all right, that is part of the realm that has intrinsic nature, which is the object in itself. Okay, in the case of the so if for some reason we say use a strict as a way to guarantee that this code has a better chance for optimizing our code, okay, we then use a sequence, but I do find that this needs to be done in one single season. So for example, like this sequence, and I want you to evaluate this. So console.log here. So evaluate that. Sequence is not an iterable because I need to invoke that function. I have a reference, and there you got it. And now it's undefined here. So that'll be all for this video. Take care. Bye bye.